Okay, so today you're going to be doing some exam questions on 2D kinematics. So on the screen are just all the formulas you might need, and anything that's in bold means they're vectors. So constant velocity, you have the displacement equals velocity times time. Or when vectors, to get the position vector, it's the initial vector plus the velocity times time. Constant acceleration formulas, well, they're just the Subat ones. So you get given those. Remember when we work with vectors, only 4 of them work with vectors. The v squared one doesn't work because at A level we can't square vectors. Variable acceleration. So you know dVA, if you go down, you differentiate. Up, you integrate. And remember, when we integrate, we always need a constant of integration. So questions signal that you need to integrate by giving you some extra information. So for example, if they give you the acceleration, they might also say at time t equals 3 seconds, the velocity was this. So that's a signal that you need to use that to find what the plus c is. Forces, F equals ma, or in vectors, F still equals ma, just the F and the A are vectors. And just some general vectors knowledge. So you know the magnitude is just Pythagoras. Speed is the magnitude of velocity. Distance is the magnitude of displacement. And to get from A to B, so the position vector A to B, you can go from anywhere to B, take away anywhere to A, which in particular we use the origin. So A to B is O to B, take away O to A. Now, we usually use that if we're trying to find a distance between 2 vectors. We get displacement first using that formula and then do the magnitude. So I've sent you a document with the exam questions. So hopefully you have a go at them yourself. Then I just want you to look at this video when you get stuck, because I'm going to give you some hints and then the answers. If I can get this working, there we go. So there's the first one. So the hints, well, first of all, you have constant acceleration. So what does that mean we can use? Hopefully you spot that means Subat. So write down what letters you have. You have ATV and you want to find U. So what formula do you use? Which formula doesn't have the S in it? Look at your formula sheet. And then use that formula to find U. But the question says find the speed. So therefore, find the speed, not the velocity. So you know how to get from velocity to speed. It was in the previous slide. And then there's the mark scheme. So you should get the speed was 20. Second one, so again, hope you've had a go at this yourself, or if you're working through the video, press pause so you can try it yourself. Okay, so give the acceleration, but this time what do you notice about the acceleration? Is it t in it? So what does that mean? We want to get to velocity. So how do we get from acceleration to velocity? Now they give you in the question the initial velocity. So remember my hint, if they give you some extra information, that means you have to use it to find something. So initially, think about what t is initially. You've got that velocity initially. So sub that in, find out what your c is, and then that will give you a velocity, which is written on the screen now. So remember, you can write that as a column, so 2t plus 2, and then 3t squared tick with 4 underneath. Yeah, I prefer columns, but this mark scheme seems to prefer i's and j's, which is fine. Okay, next one. So I'll notice in the question log, you've got the mass, and you've got the position vector. Now, in part B, just wants a speed, so we're actually not going to need the mass, but there would have been a part later on where you had to work out acceleration, or actually I think it was impulse, which is a different formula you don't need to know, do a mass. So ignore what I just said. So you've got the position vector, which again just means displacement, and you want to get speed. So think, how do you get from D to V? So remember, speed is the magnitude of velocity. Position vector tracks the displacement, like we just said. And so how do you get from D to V? Now do it to work, get an expression for velocity. Sub in t is 3 to get the velocity when t is 3, but we want speed. So then find the speed by doing the magnitude. And then the answer's on the screen there, so you should get 26. Okay, next one. So we want the acceleration. Now, it's constant force. So I think if there's constant force, what else is constant? Therefore, what formulas can we use? Okay, we've got the initial velocity. We've got the velocity when t is 4. So we have t as well, and we want to find air. So think about what formula you have to use. And then sub everything in, rearrange it to get what air is. And that'll be part A done. Then we want the magnitude of F. Well, once you get the acceleration, you can use that with the mass to work out the force. So you can get the velocity, the vector for the force, and then do the magnitude to get the magnitude of F. And that'll be part B done. And then part C, find the velocity of P at time t equals 6. So that's just testing. Do you know which of the velocities at the top to use? So you've got U, the initial one, when t is 0. You're trying to find V this time. You've got t is 6. You know, acceleration is still the same, so the acceleration of part A. So you have U, T, and A. So use the same formulas in part my step 2, my hint 2, to find V, and leave it as a vector because I want velocity this time. So the answers are on the screen. So it should be 3 minus 15 for part A, 6.71 or root 45 for part B, and 21 minus 7 for C. Next one. This time it's constant velocity. So think what formula can we use for position vector if there's constant velocity? So hopefully spot us the u equals u naught plus vt. So we have v, that's given in the question, the velocity is given in the question. We have the initial vector, position vector, so we can find the formula for r in terms of t. We can then sub in t is 2 to get the position vector for P. Oh, sorry, I've just spotted as well, actually, reading this now. I'm not going to change PowerPoint, it's going to take too long. But if you read the question, it says at time t equals 6, P to the position vector minus 4 minus 7. So minus 4 minus 7 is not the initial position vector, as I just said. Instead, you're going to have to use that formula, sub in t is 6, sub in the velocity, and sub in minus 4 minus 7 as your r, rearrange it to get what r naught is. So now you'll have r naught, then you can go on into, you have r naught, you have v, so you can find an expression for r. Sub 2 into that expression, and that'll give you displacement. So now remember, how do you find the distance? And then the marks came to the board. So yeah, can you see the first bit on that line, the minus 4 minus 7, is the position when t is 6. Work out r naught, and then get the answer. They've done theirs slightly differently. They've just done theirs between t is 2 and t is 6. But you should still get the same answer. 17 meters, hopefully. Okay, next one. So you've got v, and it's in terms of t's, so it's not constant. So again, think what you use if it's not constant acceleration. And I want you to find the acceleration. So how do you get from v to a? Then do it. Then in part B, it wants the magnitude of f when t is 2. Well, sub in t is 2 into the acceleration to get the acceleration. Then you can use f equals ma you've got M, you've got A, you can work out F, and then just do the magnitude. Done. Easy 6 marks, this one. And then answers on the board. So 6t and minus 4 for part A, and then 6.32 for part B. Remember, you can leave this as square root, but in mechanics, we tend to write stuff as 3 significant figures rather than exact form. Next one. So it's given us an expression for the force, and it wants the acceleration. So we've always got the mass. So we have F, and we have M. So we can find A. And then it's saying show that when t is 3, that the velocity of P is that. So A is variable. So think about what we use if we have variable acceleration. How do we get from A to V? Okay, and again, there's something in the question that gives some extra information in the question. They have it give us the velocity when t is 2. So think, why have they given us that? What can we work out that information? And then once you've worked it out, you can sub in t is 3, and you should get the answer 9.15, and the answer's on the board. Okay, next one. So they give us a force, and it's variable. So think, what else is variable? So think about what we have to use. And we're trying to find the velocity at t seconds. So we just want an expression for velocity. Well, if we have F and we have M, we can work out A. So you can get an expression for A. And think, how can we get from acceleration to velocity? And then think, they give us the velocity when t is 0. So use that to work out something, the plus c, and then get your answer, which is on the board now. Okay, next one. So we have the mass, and we have the velocity, and we're trying to get the magnitude of the force. We also have stuff about position vectors, but that's not needed for part A. So in part A, we have V. So think, what's the formula we need to get F, if that's what we're trying to find? F equals MA. Or we have M, we just don't have A yet. But we have V, so think, how can you get from V to A? Do it. Then use F equals MA to get F. Then sub in 4, and then do the magnitude. Okay, find the distance O to S. Well, we have V, so you can get from V to displacement. And then they give us, when t is 0, we got the position vector, so you can use that to find your plus c. Sub in 4 to get the vector for S. And then once you got the vector for S, you know how to find the distance. And the answer's on the board. Okay, next one. This one's a tricky one. So we have the velocity of the particle, and we have its position vector, and it says find an expression for the position vector p after t seconds, given your answer in the form ai plus bj. So it wants us to find the position vector. So if you look at the velocity, well, how can we get from velocity to displacement? That's one way of doing it. And then you can sub in t0 to get the position vector, to get an expression, and that's done. Or you could spot that. Actually, no, ignore that. That's probably the quickest way of doing it. So yeah, so get from V to D, so integrate, sub in t0, and the position vector is 3i, 5j, to get what the plus c is. and then you have your answer. And the second bit, so second particle Q, it's got constant velocity this time. So think about what we can use, what formula we have. If it's constant speed, constant velocity. So we've got the constant velocity. We've got the initial position vector, because it says t0. So we can find an expression for the position vector using 2i minus 3j and minus 7i. So we've got an expression for the position vector of q. And in part A, we've got an expression for the position vector of p. So to prove they collide, that means those position vectors must be equal and the two bits must be equal. So the i's must be equal and the j's must be equal. So you should make them equal, get two equations, like I said, make the i's equal, make the j's equal, solve them both, and hopefully you should get the same answer for t as the i's and the j's. So the answer's on the board. So it should hopefully be t is 2.5, it gives you the same i's and the same j's. Okay, and last one. It says constant speed straight away. So think about what you can do with constant speed. For this one, I know we normally work in meters and seconds, but this whole question is in terms of kilometers and hours. So just leave it on in terms of kilometers and hours. It just means your velocity, instead of being meters per second, it'll be kilometer per hour. No, it won't affect this question. So we've got constant velocity, so think about what formula we can use. Let's assume noon is the initial time. And I can't spell, I should say take noon to be the initial time. So what time would 14:30 be? So how many hours is it from noon till 14:30? So then you've got what t is, you've got the constant, you've got the initial position vector, you've got the position vector when t is 2.5. So you can work out the velocity by using that formula and rearranging it to get what b is. Then part B, it says find the position vector of b. So we use that same formula again, but this time we have v and we still have r naught. So just putting those things together. So that's an easy 3 marks. Then it says we have another boat C that's moving with constant velocity. The position vector is given by that, but you should notice this time is an unknown, there's a lambda, that's unknown next to that j, that was what we call lambda. And it tells us this time that C intercepts B. So it's a bit like that last question, where intercepts means they're equal, so the two position vectors, the one for both B and one for both C must be equal, so the i's must be equal, and the j's must be equal. But this time the j equation is not going to help us because it's an unknown. So what you're going to do is you're going to solve the I equation to get what t is, and then sub t into the j equation to get what lambda is. So it's not too bad to get 5 marks. Then the last bit, show that before C intercepts B, the boats are moving with the same speed. Well, the trick for this, well, you could cheat, first of all, to get the speed. Remember, you could get the velocity. You've got displacement, so you could differentiate that to get the velocity, and then do magnitude to get the speed. Or if you rearrange, or if you look at the vector for C, the bit next to the t, the 6i and the lambda j, that's your velocity vector, isn't it? Remember, r equals r naught plus vt. So the bit that's times by the t is that velocity, so 6i plus lambda j. So work out the speed of that, work out the speed of the velocity you found in part A, and hopefully they should be the same speed. So on the board, you should see that the both are, one was 2, 6, and the other one was 6 minus 2, which when you square them gives you the same answer. So the speeds are the same.